Hi, this is John Freeman. I'm the Executive Director of GLREA. I want to welcome everybody to tonight's edition of Detroit Solar Stories, which is going to be run by the Vice President of GLREA, Diane Van Buren. She and her colleague, Garrett Denault, I know I'm going to butcher your name, Garrett, so please correct me. But we're very honored to have both of you join us this evening for a really interesting presentation about how to reuse solar panels that have not, used up their life, so to speak. But before we get going, I want to acknowledge our sponsors for these solar stories. We have the Michigan Department of Environment, Great Lakes and Energy, otherwise known as Eagle. And then, of course, we have Homeland Solar, Harvest Solar, and Serenergy. So I'm going to immediately turn it over to Diane and Garrett. They will give a presentation, and then, as always, we'll open up for questions and discussion at the end. So, Diane, take it away.
Okay, I had this all set up, so let's see if it works. Did the magic work?
Yes.
That was the fastest setup I have ever had, so I'm pretty thrilled that is working. So, hello, Garrett and I are going to walk you through some ideas we have for reusing solar panels. And I'm going to start by saying this is truly a success story for GLREA because um, I've been noodling with this idea of how to use panels. My company, D2 Solar in Detroit, was able to get um, about 27 kilowatts of used panels a few years ago from a project that was being disassembled in Detroit. It was a land mounted project. Should have run out and got pictures of that before it was taken down. But you can see some of those panels in the very background of this image. Um, so we've been using them for some small off-grid projects. And I mentioned this to John Freeman one day, and he said, "Oh, you should talk with John Kinch, who's also a board member and now president of GLREA." And so John Kinch and I started this conversation, and it turns out he had been working with Michigan Energy Options, his organization, with Next Cycle Michigan, um, which is funded through Eagle, and it's part of Centropolis at Lawrence Tech and other organizations where they're looking at the whole circular economy, right? And with the circular economy, you try to keep things out of the landfill. If you think of the pyramid of reuse, recycle, etc. The idea is that you never finish using things. You just continue to find new uses. So we started working out some ideas based on what his research had done. And I am now enrolled in the Next Cycle program and working through that. And we were also able to get a grant together so that we can start to implement some of these project ideas we have. So this is the first blush explanation of what we are doing. And we thought, what better location to make these announcements than GLREA, which can take credit for helping to bring these partners together and really help try to solve a problem that we have, um, that we will have in Michigan by 2050, which seems like a long way away, but this will be coming very quickly. You may recall that last summer we had a speaker, and maybe if you did not have a chance to see that, you can go through the archive of the solar stories. But that was with Dr. Anik Ansel from Michigan State University, where Michigan State's been looking at the idea of recycling solar panels. So she's taking that other approach, which is um, first doing the research of what happens to solar panels if you put them in the landfill first. And so they've been doing a lot of research on how much leakage is there. There's different chemicals. Is that a problem? But the more important problem is That's a lot of tonnage that could be going into landfills that doesn't have to go there. So with her program, she's been looking at the whole economics of taking them apart, researching. It's a really good primer on the longevity of solar panels and the case for recycling. In our case, we're looking at reusing first before you get to that recycle stage. So it's our intention to try to test the feasibility of how to recycle these panels, reuse these panels before they have to be recycled. And the best case scenario for that is for us to put it in community use where they can provide the most power and the most economic efficiency. But we also want to have the next 5 years of time to test those and to create a database of how effective were those panels. So the theory is that they will last another 10 years. If they're coming down in 2025 and they were only installed in 2015, for example, how many more years can we get out of those? And for all of you in the solar community, you know that what used to be the standard of a 220, 230 panel has now been doubled. And so as the installers are able to say the amount of space you needed for a 220 system, you can now double the production with the 550 system, right? So that's in the case now of what some of these repowering systems are happening. We're expecting 10 to 15 more years of life out of those. The image you see is one of our projects we have done, which is a community park in Detroit. And it's a model of a pavilion idea that we've been working on now for a couple of years. Actually, several years. Garrett and I go back, it turns out, several years ago when we started to pilot this idea with urban farms. In this case, the panels are powering a battery system that you see on the side there. And that sculpture in the back, that's a piece of artwork for the park. But in fact, it's also holding up, it's supporting a air monitoring system. And at night, the electricity is making that system glow. And I wish I had a picture at nighttime, I don't. But it glows. And it's kind of cool because it's color coded with what the air quality is as it's moving through the different days and weeks and months and years to be able to record what is the air quality. What's important about that sculpture is that it's a half-mile from the Stellantis Chrysler plant that's located in Detroit and actually does have a big community concern with the air quality right next to it. So it's a very interesting way that we were able to provide the panels. And they're use panels. They don't need 550s up there. And in fact, the battery couldn't support a 550. It'd be trying to take a fire hose to a glass of water. So that's one of our solutions we have been doing already. So our goal is to find new uses for old panels. And the idea of how many panels there will be in the future coming down, and as they're coming down more and more quickly, finding additional new uses for that. In this case, you're looking at Grover, as you can see. Grover is a D2 solar, actually Solar Party, which is our sister business, which rents out solar-powered battery systems for events. And in this case, Grover travels the city all summer long, powering music festivals and bouncy houses and other kinds of community events. But those are all 220s on there. So Garrett's going to walk us through a little bit about how off-grid systems can support urban farms. And I realize that I don't know for you guys if your pictures are being dwarfed there, but see if you can see them. Garrett,
Yeah.
walk us through these systems.
Can everybody hear me?
Yep.
Yes.
Okay, cool. Yeah. So I am an advocate. I'm an installer in the field. I've been in solar since 2016, I believe, and never left. Been pursuing a career as a journeyman electrician also, and this been my as I go. But the three pictures on the right are my backyard. I live in Hamtramck. So I've been always interested in off grid. I went to the Earthship Biotexture Academy before I started my solar career, which for those who don't know is a off grid housing um, university that you can go to in New Mexico and you can learn to build off grid housing and things like that, which sparked my interest in solar and off grid living and just like off grid electricity and housing in general. So that started. I'm also an avid gardener in my backyard and in my tiny little Hamtramck backyard, which is one of the only south-facing properties in the city that actually can get sunlight and grow some stuff. So what you have here is my shed after people came over for a little garden party and painted it. But I used renewable or not renewable, reused solar panels that I had gotten from work that were actually locally damaged. So let's say what happened in shipping, a forklift broke a bottom of the panel or something like that, or there was like hail damage or something like that. A lot of these panels were not able to be used in residential applications anymore. So there's stacks of them in these solar companies all throughout the metropolitan area where they won't be able to use these panels anymore, but the localized damage will allow them to like still produce. So what I did was I used those panels from work with permission of my boss, and I installed them on my shed, and I built an off-grid system that powers rainwater catchment that I get from my house, that I then power up and irrigate all of my garden and native Michigan plants for edible food and also for native Michigan plants that I have in my backyard. So this would be an example of a system that I designed and built that's not an all-in-one package like you would get from like a generator you can buy or something like that. It's got all the individual componentry that I assembled. But I've had the system now for 5 years, and the panels charge of the batteries to full every day, even with just two panels. Um, I have two 80 amp hour batteries, so it's not like a huge system, but it is enough for me, my little needs. I can power all my tools for work every night with it, and I can power up my pumps, and everything's running off grid. So I have a small amount of power in the event of an outage. I can charge a laptop. Neighbors can come over, charge their phone up if the power goes out in Hamtramck, which happens often because the grid is a little bit iffy in my area. So yeah, that's what you're looking at there. And I've also done a number of other projects for farms in the city and through companies I've worked for and also independently about. But I share a passion for irrigation, and I see that these farms, like a big hurdle that holds a lot of them back from becoming more productive is a lack of power and water on site. And I started to build these systems in my house as like a proof of concept. Obviously, like it would work if you have the power to do it, but like how much does it really cost? Is it affordable? How can we? And also, it just makes sense that Diane and I would work together because I also reuse these panels just from the beginning because they were being thrown away basically. But if you do like power tests on them, you're like, these panels are producing two-thirds capacity even though they're damaged. And those are just panels that aren't, a lot of these panels that can be reused are older and have less wattage, but aren't damaged. But at my house, the panels are also damaged and they're still producing enough to power up my whole system off grid. So I think that's super cool. So yeah,
So
that's kind of my
Garrett,
background.
walk us through the power system itself.
Yeah.
What's involved in that far right? I can see that you've got your batteries and the inverter, but can you give us more details about what the power system is that you installed and
Yeah,
how it's
sure. So
working?
all I did was, I mean, there's not that many components. This is pretty bare bones, but what you're looking at is a Victron charge controller and a 3 kilowatt Renogy inverter with two valence batteries that are medical grade batteries that I got for very cheap because basically hospitals have to get rid of these batteries after a certain point because they're usually used for life-saving equipment like respirators and things that need to be powered 100% of the time. So once they reach a certain depth of discharge, like capacity, I think it's 80 or 90%, they have to be removed from the hospitals, and they go up for sale on eBay. And I got them for very cheap at the time. But what you're looking at there is just my inside of my little shed there. On top of the shed, there's two solar panels that are mounted on Iron Ridge rails. And then I ran the PV cable directly in the back so you can see it coming behind the particle board. And there's like a Victron charge controller, a battery bank, and then what that powers is an extension cord that I can plug in all of my tools into, and also the pump that irrigates all those garden beds that I built, and then the ones that you can't see in those pictures. But yeah, it's pretty simple setup. It can be expanded. You can run those inverters to like a sub panel and power lights or conduit. You can run plugs or lights or whatever. It's really expandable, but this would be an example of a system that you can get the componentry and build it yourself rather than having a all-in-one unit. The batteries come with a built-in BMS, so I don't have to like add any other components. The Victron has Bluetooth capabilities for monitoring capabilities, so you can plug your phone in. It's also got a direct Ethernet cable you can plug in to check any of the production data. But mine's pretty stripped down. I think I did it for, I think at the time I only spent like maybe $1,500 for like all the componentry, not including the panels, which I got for free. But yeah, that's
And
my
you did the labor yourself too. So
Oh yeah,
that's
did it all myself.
yeah,
Of
yeah.
course.
So some of the lessons that you learned, and we really have to be honest, urban farms would require much more battery, of course, to be able
For
to
sure.
handle the amount of pumps that they would have. And another scaled project is to the left, and this is what we were experimenting with a few years back, where partnering with Keep Growing Detroit, we used their model that they were developing for water catchment systems. And so I think we put up 4 of these in total. So there would be 2 large water tanks on each side of, and you can kind of see the little gutters there. This is as it's being built, so it's not completely done. And then we would install 2 to 3 panels. And the panels were basically used for the same kind of thing that Garrett put in his systems, so that there could be enough power to run the pumps as well as some ancillary cell phone charging or power tool charging or whatnot. We are working now with 3 different organizations in Detroit, the Black Farmers Network, a composting group, and then also an environmental group in Southwest Detroit, that are all very interested in these pavilions for different reasons. The Black Farmers Network is looking at larger farms that could be 2, 3, even 4, 5, 6, 7 city lots, all the way up to a full block. So we will be designing systems that can support much larger panel projects and much larger battery systems, because those will require a lot more water and also a lot more power to push that water through the pumping system. So that's one of our challenges there. So that's our big project, the big dogs that will be going out. Another group is really interested in how the electricity from the solar collection can be used to support large composting systems out in neighborhoods. So Detroit's getting very active in the composting world to help reduce the amount of food waste. And again, these are systems that require power, electricity, but they don't necessarily want to bring in a DTE line. That's overkill. For about the same amount of money that it would take to bring in a power line, they can build a system that will give them year-round electricity off-grid. So everybody's very grateful for these ideas. So with the composting folks, their projects are much, much smaller in need, but they do want to have a system that can heat their compost throughout the winter, as well as have the same kind of idea of we need lights, we need cell phone charging. There's some power tools. They've got these drills and things that they use with their composting as well. And then the third example, excuse me, goes back to more of that park idea. And that's kind of the medium scale.
Diane,
Where
are we supposed to be still seeing Garrett's slides, or are there new slides we should be seeing?
Oh, I could go to the next slide, yes. But I don't know why I can't. There we go. No, actually, we are.
There we go.
Okay. This is one of our groups. This is the group that's taking the solar panels to that park. And so this is where we're going to be partnering with community organizations to install these different size solar pavilions with the batteries. So we're looking at these three models for how community groups need them. The idea of the urban farms, and there are 220 urban farms, not backyard farms, urban farms in Detroit right now. And it's not a unique phenomena. There's urban farms throughout the state of Michigan, all of which have the same issue of if they're not connected to a water source and a power source, they're pretty much at the mercy of the elements and having to be very creative about how to get that water. In some cases, the city allows them to tap into the fire hydrants, or there's very nice neighbors close by that allow them to hook up water. But water is pretty essential to being able to have a successful farm. The pavilions are probably not going to supply all the water they need, but it does help get through a large part of it. With the composting, the same thing. They don't want to have to bring in that power line. And then the third, with the community park, they actually have a variety of uses. We've been working with this one group, and they want to be able to set up a microphone system. They want to be able to do everything from Wi-Fi to e-bike stations. So we're testing out right now, how much power are they really going to need? What size batteries do they need? What's the best system for installing those batteries? Should we just get these new Jackery or, the new kind of Enphase all-in-one battery for them? Or is it better to design from scratch as we did in the past with the other ones? The second part of our project, though, and I think it's just as critical that I opened with, is how do we prove the effectiveness of these panels for the next 5 years so that we can give some assurance to people that when they get their panels, they will last. It's not, it's a used car, right? It's the same idea of, how long is this thing going to last? Is it really worth it for me? I find it interesting that inverters have a lifespan of 10, 15 years if you're lucky. And these might have a similar lifespan. And for things like urban farms or these parks, that just might work out very well, that they go hand in hand together. And we believe that the amount of solar panel reuse will match. We're going to see if we can keep up in the beginning here with how much is going to be coming down. Because we know that with the state of Michigan's energy goals, more and more and more solar is going to be installed into is it 20 gigawatts we're talking about now by 2040? Someone can probably correct me on that one. That's a lot of solar panels going up, and that means that's a lot of solar panels that will be coming down eventually. A lot of research is going on right now to determine how to harvest the materials out of those solar panels that are very valuable materials, but in very small quantities. So the cost of recycling a panel can be $15 to $40 versus reusing a panel, which is what we're recommending, which could be more like $10 for us to take it down, get it redeveloped, and back out into the field. Again, this is what we're testing. This is what we'll be looking at for the future. So our market validation, what we're proposing is that over the next, and actually that was very generous when we said 1 megawatt of panels, 4,000 panels between 2025 and 2026. We've kind of looking at how many can we do? What will this truly be? It would be lovely if we could manage a project like that. In the meantime, we're also working with the city of Detroit already on community workshops so that we can give residents and organizations a chance to really see how they can utilize these panels, what their funding options are. And then again, those 3 different uses with the pavilions. There's also a big interest now in block club community solar, which isn't in this initial pilot, but it's bubbling along pretty fast, and it might be coming by the summertime as well, where there might be some used panels used as hubs. So if you can imagine a city lot with 20 kilowatts, a shed similar to what Garrett had, with enough batteries in there being charged that it could be used for resiliency projects. Big interest in that. Or shipping containers, where the shipping container would be utilized for warming centers in the winter, cooling centers in the summer, food storage, lots of different uses. But again, off-grid, it doesn't have to be connected to DTE. And then there's even some interest, we're not going too far into this yet, with home installations. What the economics would be of using used panels instead of new panels if it's going on a rooftop. What we intend to do is test and track each of these systems. So our goal is that every panel that we refurbish, we're talking with Goodwill about partnering in a job training program on how we bring in the panels, test them, and then track them by putting on a new barcode. And then those barcodes will be tracked with each of the monitoring systems that goes out into the field so that we have a way to have this data result. We're working with Centropolis on that testing. And then our goal is that will the retail sales of used panels increase? We just need to be able to have that kind of testing. So we've pioneered this field in the beginning with that original 17 kilowatts back in 2022. We've been using them, and we know that people like using the used panels. When I explained it to the group in Southwest Detroit, which is Southwest Detroit Environmental Vision, they were ecstatic over being a pilot for using recycled panels or used panels, because that fits their organization profile exactly, that they would be part of this marketing and this test. We love that we're partnering with Michigan Energy Options, and their part in this is, get out your pens and paper, because we're going to be talking about this in the future as well. We're looking for used panels. So right now, this isn't a very big field. We want to know what's happening with the used panels. Can we be a conduit for receiving those panels as they're coming down? And again, DTE, we've learned recently, has had deinstallations of some of their solar fields for various reasons. In one case, they lost the lease on the land. In other cases, they might be repowering to upscale their system. So MEO is going to be working with us, and that's their part of the project, is that they're going to be the conduit as a nonprofit for receiving those panels. And as far as we know, we're the only company in Michigan working to find new uses. So this is very rough. Don't use your pen and paper on this one. It's really just the back of the envelope. But what we're looking at is, if we had 4,000 panels to recover, how would that be divided up? And what would the cost be? So as we're fine tuning in the next year, we'll have much better numbers. We're looking for the urban farm, though, that it will be a 5 kilowatt system. And we're also looking for the funding support and partnership with those organizations that are receiving them so that they can develop their projects. So the best part is it is a triple bottom line impact. We like to think that solar is absolutely a sustainability answer. The problem is it's not sustainable if it doesn't have a second life. It's not sustainable. It's not part of a complete circle if it's discarded in the end. But we feel that if we have 1 megawatt of solar panels placed in service for the next 15 years, this is part of that triple bottom line that we're able to contribute. That those panels will generate 20 gigawatt hours of electricity that otherwise would have been wasted. Even if it's recycled and taken apart and materials sent back to whatever, you've lost 20 gigawatt hours of electricity. That would mean over 2 million in savings from having to bring in DTE and pay for those same gigawatt hours for those organizations. Keeping that greenhouse gas and CO2 out of the air is critical. And imagine that, and I'm not sure this number is right. I really do have to work on this. It seems like it would be a lot more than 120,000 pounds, but that was my number so far. We think we'll have at least 20 jobs created, full-time jobs, probably many more, but that's our first guess on the handling of the materials. And it's a priceless community pride to be able to say, look at what we did. This is ours. So we're looking for a little help from our friends. These are some of the areas that we're continuing to seek out support, especially those expertise partners. The best part with being part of Next Cycle is that they really are working with us on these, but I thought I'd open this up to GLREA membership as well, because I know there's a wealth of information and ideas out in our community as well. We are working with Centropolis. We are working with experts with Next Cycle, but we're certainly looking for any support or ideas or creativity that's within our own GLREA community. So those are our used panels on our own project. This is our warehouse. And those panels charge batteries in the building, and they just hum along just fine. That was from our original deployment. So we can now open it up for questions or conversations, let's say.
Yeah, let me ask the first question, and then we have a couple questions on the chat we're going to get to from Forrest and Joe. Diane, I'm sure you've thought of this. This is an obvious question, but I still want to tee it up for you.
Oh, okay.
That, low and moderate income people, because we don't have community solar, if they don't have the money to pay for a full system, it's a barrier. But
Absolutely.
if these used panels can therefore be sold at a significant lower cost to lower and moderate income families, then maybe more people can get solar because the cost is just dramatically less. And so I'm just wondering whether you thought about creating a market to sell to lower income families. And then part two of that question is it possible that IRS would still give a 30% discount if a family buys used panels to install on their home? Have you thought of that?
Okay. Question number one. I hesitated with the home installation at this point because we do want to do this market validation first with how reliable are they, right? So the urban farms do support low-income families because that's a food system here in Detroit. The whole idea of having these hubs, there's 3 or 4 neighborhood groups we're working with right now that are really interested in those resiliency hubs so that they can have a backup when the power goes out, or they can come charge stuff at the hub very similar to how Garrett explained how his works with his own neighborhood, that it's a handy thing to have. So again, supporting low-income communities through these hubs. And it could be the solar farm itself is the hub, right? Um, we've been talking a lot with the City of Detroit. Both Diane C., my solar partner, and I are very deeply engaged with City Sustainability Office and different projects. We thought we had a big Solar for All grant coming to Detroit. We were talking about how much of that could be devoted to rooftops for low-income households. The reason, again, that we hesitate on the use panels for rooftop at this point is the longevity, but also they're not going to, if you're a low income family, you're not going to get a tax credit, right? So looking at other options for how low income families could benefit from solar. Apartment buildings would certainly benefit from this, but the use really has to be tied with that shorter term thinking that I'm okay with 10 to 15 years. I don't know how many people own a home for 10 to 15 years anymore. I'm, in this anomaly group that I've had a house for 20 years, and I realize it's not as popular anymore to stay in the same place. But so that answers, I think, that low income. Plus, the panels aren't the biggest part of the cost of the project anyway. So if we can shave a few pennies off a rooftop system by using used panels, I'm not sure it would make as much economic sense. The other part of the question with can used panels get the full tax credit, I don't know. I do know you can get the balance of the system with the tax credit. Everything else, I don't know the answer about the used panels at this point. We'll have to ask some tax advisors. So again, the benefit of starting this project with nonprofits, with community uses, none of these are really looking for the low income or for the tax credit at this point, unless they go for the balance of the system.
Sure.
And then they'd be able to get that.
Okay, we have two questions on the chat. One is from Forrest.
Hi, Forrest.
He's asking whether you've had any grant funding to support this project from the state of Michigan or maybe private foundations like maybe the Kresge Foundation downtown Detroit or whatever.
The grant we have received at the beginning here is through Next Cycle, and MEO and D2 Solar went in on the proposal together. And we did receive an award of over $100,000 that we're using. Of that, we have about 40,000 going to help support a few pilot projects. And we're looking at community organizations that can also bring some funding to the project so that we can stretch that 40,000 as far as we possibly can. We also received some of our funding to help set up all the testing and the validation systems. And then we're getting a lot of technical assistance from the Next Cycle program as well through Centropolis and Lawrence Tech to set up how these testing systems might be working.
Sounds great.
We will be definitely going for more grant funding with the individual organizations. So with the Black Farmers Network, with the organizations that want to be able to build these. That's the great thing. They'll be able to also go after grant money as nonprofits.
I would definitely talk to Dan Radowski from Centropolis.
Oh, he's deep. Yeah, he's fully aware.
He's a
spent a lot of time.
magician for
Yeah,
getting grants especially from the
Yeah.
state of Michigan.
Yeah.
Joe DeForest has a question, and then we'll open it up to Dave Curtis. If you receive panels from different sources and the panels have different outputs, can they be joined in an array, or how does that work? And similarly to racking, do racking systems accommodate different panel dimensions?
Garrett, do you want to take that one?
Yeah, that's a good question. I can answer that question.
Yeah, good. Okay.
So there's different. It's not an all-inclusive yes, but when you use what's called maximum power point tracking, So when you're dealing with off-grid systems, not to get too technical, there's two different types of charge controllers you can use. There's pulse width modulation and there's maximum power point tracking. All of your like grid tied systems that are common on household roofs are all using maximum power point tracking technology that's present in the inverters, the micro inverters, and also in like optimizers and things like through SolarEdge and other popular inverter companies. Maximum power point tracking allows you to put different panels of different voltages together. If you use like string inverters, you should try to do them all the same voltages. Like you should try to keep panels together. But there's different ways you can design different systems to allow for like different panels. Um, but basically, what you'd want to do is you'd want to use charge controllers that utilize MPPT software to allow for different types of panel voltages to be charging the battery. Is basically the answer. So the answer is yes. And as far as the racking goes, a lot of these systems would be small. I would say you'd want to use the same racking. My system though, when you go to like build a system for a residential job or a commercial job that uses a racking system, not a ballast system, there's scrap pieces of rail that are aluminum, so they don't weigh a lot, so they're not really like valuable if in the scrap yard. So a lot of these companies, if the rails are less than the width of the panel, it'll be discarded or it'll be scrapped. It'll be sitting at the warehouse with no use, basically. In my backyard, also, I have reused rails. So instead of buying all new racking and going to an electrical supply warehouse, I just splice the rails together because it's the same like splicing mechanism to join the rails. The flashing mounts on my roof are new because I don't want my shed to leak, but everything else is used. So the groundings are reused, the panels are reused. A lot of the systems are you can reuse the racking as well, honestly. And there should be some sort of like recycling program because you're saving more money recycling the panels and the racking because all this racking is aluminum. And like as we know, if you go to the scrapyard, copper is what you want. There's no racking made of copper. It's all aluminum. It's all lightweight. So there is a potential to reuse racking as well. Certain brands more than others, but like a really popular brand like Iron Ridge, which is what I have on my shed, definitely can be reused. Um, Obviously, if it's like super damaged, you don't want to do that. But if it's just old, or if there was a replacement and there's new ones, say someone got a new roof and they wanted to put up new panels and new racking because they're already replacing the equipment, or these big commercial projects on like commercial spots like banks or something like that. Like I know Chase Bank did a ton of them. All of them are on metal roofs, so they're utilizing racking. They're not just utilizing, a flat roof ballasted system. All those can be put on these gazebos and also on the shipping containers, which we've done. So yeah, the answer is yeah. That there you can mix and match any of it, honestly, and it really depends on the downstream equipment about the charge controllers because there's input voltages to get that are required, and if you put them all together with different input voltages in a string, then it will affect the componentry downstream.
Let
So
me add just quickly, Garrett, that for most of the pavilions and shipping containers and whatnot, you don't need to mix and match because it's going to be 1 to 2 kilowatts, right?
Another good point.
So if we're taking down 20 kilowatts, 50 kilowatts, or whatever of these systems, part of our protocol that we'll be utilizing for the disassembly is the very careful process of removing so that nothing is damaged. But then also when they come back to the warehouse, they'll all be, again, barcoded. And part of that barcode is to show the size of the panel, the brand, et cetera, and then keeping those together so that as they go back out, hopefully we'll have a system that's pretty well in place to keeping the cats and dogs separated.
Mm-hmm.
go ahead, Dave Curtis. You're on mute. Go ahead.
Thank you very much.
Hi, Dave.
This is right up
We,
my alley
do we
because
get to see you, Dave?
it's well,
He's
maybe
being shy.
hold on. Let me see.
There you go.
Here I am.
Hi, Dave.
Woo! Um, it's right up my alley because I would like to save the money from having a big system installed,
Mhm.
whereas uh, what Garrett has is exactly what I would like to do. Maybe 4 panels, auxiliary power.
Mhm.
Um, and I think that in another aspect of used panels might be used charge converters or controllers.
Charge controllers, yeah.
Yeah, if there's still life in them, right?
Sure, sure.
Yeah.
And I understand that, but at this stage, it would be assisting you in, how is the lifespan? How is the output of those panels? How,
Mhm.
does all that stuff work together? And I'm a do-it-yourselfer kind of person, so like Garrett, um, I would install it all myself. Used racking would be wonderful. I'm really thinking about a carport
Mhm. Right.
installation.
Use something that's already existing, right?
Hmm.
Right,
That,
right,
yeah,
exactly.
you don't have to build a whole new thing.
Right, right.
Hmm.
That's my comments.
Okay, well, we're going to talk a little bit once we get through questions about how people can get involved if they want. So that's great. Marshall, I'm gonna, if you don't mind, go out of order here for a second. I see Bill Stowe is on the call, and Bill Stowe has been working with us with MEO and just doing great contact with groups like Michigan State University with their Sustainability Business Center. Bill, do you want to give a few minutes about what you think MSU might be lending to this project?
Yeah, I'd be happy to. Well, one of the issues that we're trying to study, in addition to all of the great things that Diane and Garrett are doing on the back end, is the front end. If you were to have an ongoing business in Michigan, um, what are the steps that you need to go through? What is the supply chain from the beginning of the need to the finish of the project? And currently, right now, there is no solar panel reuse supply chain in existence. So we're essentially trying to identify what that would be, and define what it would be, and then utilize that for the flow of panels through the system for Diane's use. Uh, One of the collaborators that we're using is Michigan State University, in addition to Centropolis. Um, their supply chain school, according to their own website, is listed as the first in the nation. So they have quite a bit of renown in doing this, and they have several professors there that are very enthusiastic about getting their students involved in the sustainability issue of this project. The circular economy approach, taking materials that otherwise would have been just thrown, right now they're just taken to the landfill in most cases and disposed of that way. And taking that and putting it back in circulation for reuse, as Diane has already described. So the supply chain school, and within the supply chain school, they have and I won't get this name completely right, but they have a Center for Ethical Leadership. Um, and their students are going to get involved as well and help set the value chain. And in other words, what is the economic value of doing this in the first place? And then the supply chain school is going to work on the different steps from procurement to warehousing to manufacturing to delivery. So
What a
it's pretty
resource.
exciting to get all these folks together. So thanks,
Yeah.
Doug.
And, giving students a chance to participate is just so precious. And I was surprised that the response they had was, we would love to do a sustainability project. We would love to do thinking, oh, it seems like it should have just been natural by now, but it wasn't.
Well, one of the things that's really worked out well, and this might be of use to other members on the call if you work with universities, um, typically their overhead is like 40 to 60% of the total amount of money that comes in through a grant. And many times that takes them off the table from being able to help because you don't have money for the actual project. In this case, the professors have agreed to set up a consulting system for the students. So the students would be working for the project for D2 and MEO as opposed to the school. The school would recommend the students, they would get vetted and then they'd sign an independent contractor agreement and we'd work that way, bypassing all the bureaucracy and the excessive overhead.
Plus giving them a great little piece on their resume.
Right. That's a real business.
It's
Yeah.
a real business. So that's really exciting. So Marshall, I thought you wouldn't mind a little Michigan State plug going in front of
Go
you.
green. About to win a championship here in about 8 minutes. So,
Oh, okay. We don't want to stand between you and a basketball game,
yeah.
but
No,
did you have a
I'll
question
write
too?
championship. Yeah, no, more of a comment. So, the general belief is solar panels have a 25 to 30-year lifespan, but really there's a misconception that, say year 30, the panels just don't stop working. They just
Right.
degrade in efficiency. So every year past 25, 30 years, they decrease 1 to 2%, which really isn't that much. So, this is a great business model. There's a huge potential. The original solar panels of, the 70s, 80s, 90s are, going to be coming offline as efficiencies and wattage is improve. So, I'm just, commending you, Diane, and MEO, and just happy to plug in. I've been doing this work for 10 years now with recycled panels, recycled batteries. So just happy to see it take off.
Yeah.
I've worked closely with groups in Ohio that have recycled batteries and panels. And so there's an interest and a need, and it's good work.
And I'm surprised no one asked about the batteries because there is talk, we haven't formalized it yet, but General Motors, which happens to have a presence in Detroit, seems to be receiving a lot of batteries now that are at 50% life that they need to replace out of their Hummers and other vehicles. And so some of the urban farming groups are also looking on their own with what could they be using batteries for and if they could receive those as donations. So those two, while we haven't formally put it together, they might drift together at some point as well. And again, it's for the same reason. There's a valuable asset that doesn't serve its purpose as it was intended in a Hummer, but could certainly be used in a facility like the smaller systems that like Garrett has.
Yeah, I posted in the chat, but I personally have upcycled tens of thousands of lithium ion batteries from old
right.
laptops, vaporizers, you name it. And so the batteries can all be upcycled. Oftentimes the cells just need to be jump started, much like you're jump starting a car. You resort the cells on how many milliamp hours, which is effectively how many lives are left in the battery. So there's great potential. And so, it's a market that hasn't been touched. So, happy to plug in where needed.
Great. So I just only have a few minutes left. John Freeman might be able to help us with this a bit, but we're looking for panels and we're looking for anyone who might want to be able to provide any expertise. I see a lot of names on here of folks that I know that are out there doing some really great work. If you know of a project that's being repowered or that has to move, that has panels that need a home, will be your Humane Society for Unwanted Panels, but also that level of expertise. So, John,
Diane?
with your permission, we'll start that conversation.
No, I think that's great. There might be, and I recall a few years ago when I was talking with the gentleman at McNaughton and McKay out of Ann Arbor and Madison Heights, that I thought that they might, in fact, take old panels and take responsibility for getting rid of them when a solar installer buys panels from them. So we should check with not only McNaughton and McKay, but we should check with some of our business members, Harvest Solar,
Mhm.
of course, Ken Zabara and Alan O'Shea up at CBS Solar, and
Mhm.
Mark Haggerty at and Solar Solutions, and for that matter, Strawberry Solar, because
Right. Yeah.
I'd be they might know about whether some of the manufacturers of panels actually take used panels back and assume responsibility. My
The only
second,
one that does is First Solar in Ohio. Um, what DTE is doing right now with taking panels down, and they're very interested in this. And me and DTE don't get along. DTE and the I don't get along, but the problem that they're having is they want to be responsible when they're bringing panels down, but they're sending them all the way to Texas to a recycler. And to me, again, that's that same situation of you're leaving those kilowatt hours, those gigawatt hours untouched if you're sending them all the way to Texas.
well, that's my
Um,
second
yeah,
comment, Diane,
yeah,
is
okay.
that we should think about state laws that we
Hmm.
could maybe introduce and get enacted that would support the formulation of this marketplace.
Absolutely.
Whether it would
Yeah,
give DTE a tax credit for giving panels to a nonprofit versus transporting them to Texas. Maybe even adding on a fee to every panel that is sold in Michigan. It's almost like a bottle deposit.
yeah, yeah,
They pay the fee up front, and then when the panel needs to be taken down, the D2 Solar gets this fee in order to pick up the panel from the home that it's taken down from or something. So
right, right.
some way
And
of,
that's MEO's working on that system right now.
okay,
And again, that great talk that we had from Anik last summer, she showed how many states were working on that kind of legislation. And it's more an end of life plan that when you get solar of a certain kilowatt, megawatt, whatever, for the big industrial size, you must have an end of life plan
right,
in place.
right.
So we don't have that in Michigan. In other states, they're starting to require
Well,
that.
that's not quite true, Diane. Anytime a developer is putting up a utility scale solar, they have to put money in an escrow account in order for the panels to be taken down 30 years later. And it must be done in a way because the developer may not be around, but that money's
Yeah,
got to be
yeah.
put in the kitty up front in order to guarantee that funds are there to take the system down the road.
Hmm.
So,
Hey,
And they're
John, this
doing
is
that in Detroit with the big solar farms going in Detroit. There is part of that is in place too.
the legislation you're talking about, and I think Minnesota just recently passed this, is product stewardship legislation, which basically states that in this case, anyone that sells a solar panel in Michigan has to pay a fee, goes into a fund, and that fund is used to reclaim and recycle all of the panels.
So it's on the solar installer, when you're saying anyone who sells,
Whoever,
or is
the,
it the buyer
well,
who's,
the
it
seller
would
may
be
pay it, but the installer may pay it, but they're going to pass the cost on
right,
to the
right,
right.
buyer, of
okay,
course, you know.
Right. And
okay.
it's not hasn't been used too often on solar panels. It's typically used on just recycling commodities like
Hmm.
packaging and things like that.
Okay.
But Michigan should have a policy on product stewardship for panels.
Well, Bill,
But
if you could send me any information you have about the Minnesota law.
Yeah,
uh,
I will.
we're talking
that's
about
great.
coming up with a series of bills in the John Richter's MPSC policy committee that we have within GLREA. So that sounds like a great idea for a bill to be introduced. And
Right.
before I forget, Garrett, can you put your contact information in the chat? Cindy from Midland, she wanted to be able to get a hold of you, email as well as your phone number. It's 8 o'clock, Diane. We probably need to wrap this up.
Well, and I know we've got a basketball game to go.
That's right.
So I'll throw my info back up there real quickly. Is it showing? Probably not. I didn't share. But I'm GLREA. You can reach me through Jen Freeman and others. Greatly appreciate it. Next month will be Ann Arbor. We're alternating now. So you'll see us again in May, and maybe we'll have an update and another solar story from Detroit.
Well, thank you very much, everybody, for joining us. This is Diane. Thank you, Garrett. Thank you. This is a wonderful concept idea, and we're 100% behind you all. So great job. So
Thank
thanks,
you.
everybody.
Thank you.